In this video, I'm going to be doing another example of a related rate problem. So take a minute and read the example. Okay, so first thing that we always want to determine when we're doing any type of a word problem is, what are we looking for? Well, we're looking for two things. First of all, what is the current tuition? And secondly, how fast is the tuition per credit hour changing? It's the second part that tells us that this is a related rate problem, because we are looking for how fast something is changing. So to get started, we want to write down what we know. Well, first of all, we know that we have a demand equation. So I'm going to write that down. Q is equal to 440p minus 0.7p squared, where Q is the number of students and P, or price, is tuition. Tuition is a form of price. Now, remember, with a related rate problem, we need to be given a fixed number or a constant, and we need to be given some type of a rate of change. So in the next line, it tells us if the current enrollment is 6345. So that would be the number of students, or Q, right now. Q is 6345. That's a fixed number. That is occurring right now. It's not changing. And is increasing. Here comes the next part. Here's our rate. It's increasing by 1849 students per year. That means the rate of change of Q with respect to time is 1849. So we have our fixed number and we have our rate of change. And so number one, we want to find P. Want to find P. That's the first thing we want to do. So to do that, all we need to do is go to our demand equation right here and say, okay, well, we have Q. Well, I'm not going to rewrite it again. We know what Q is. We know that Q is 6345. So 6345 is equal to 440p minus 0.7p squared. Well, this looks like a quadratic function. So putting it in standard form for a quadratic function, which is set equal to 0, whoops, forgot my constant, minus, so I'm putting all this stuff over to the left, so it would be plus 6345 equals 0. So you can use this will not be factorable. You can use the quadratic formula, or you could graph it in Desmos. And when you graph it in Desmos, here's a cute little trick some of you may remember. When you graph something in quadratic in Desmos, and your quadratic is set equal to 0, and you're trying to solve it, your solutions are where it crosses the x-axis. So that, or the quadratic formula, when you do that, you will end up with P being equal to, you're going to have a negative number, negative 1410, and P also being equal to 642.68. Well, we're not going to offer a negative price per credit hour of tuition, so this can be disregarded. Usually there's going to be one answer that you want, and the other one, for some reason, thinking about it logically, can be disregarded. So price, the tuition is $142.68 per credit hour. That is what that is. This is your tuition. Tuition per credit hour. The second thing we need to do is, how fast is the tuition changing? So to find out how fast the tuition is changing, that would be the rate of change of P with respect to time. So to do that, we need to find the derivative of our function up here. So we were given we were given our demand function. We now want to take the derivative of that. And so when we take the derivative of that, we will get, so let me just write here so we can see it. We have Q is equal to 440p minus 0.7p squared. So the derivative of Q with respect to time is dq dt. It would be 1 dq dt. The derivative of 440p, p also being dependent with respect to time, is 440 dp dt. And then this would be 1.4p dp dt. Okay, so now we want to solve this for dp dt. So on the right-hand side, let's factor out dp dt. And we'll have 440 minus 1.4p. And that's equal to dq dt. So dp dt is equal to dq dt all divided by 440 minus 1.4p. Well, we know what this is, and we know what this, so let's just plug them in. dq dt was given to us as 1849. And we calculated P as being 642.68. 642.68. And when you stick this in Desmos of your calculator to figure out, you should end up with a negative 4.02. So dp dt is negative 4.02. So what does this mean? Remember that P is tuition. This is the rate of change of tuition. Because the rate of change is negative, that means tuition is decreasing. How much? $4.02 per credit hour per year. So tuition is decreasing by up to $4 per credit hour per year. All right, well, that's a good thing. Tuition's on the getting lower. It's on the decrease. All right, that is this problem.